Hello again, Year 8. In our second lesson on probability, we are going to be looking at how we can create a list or something called a sample space to help us calculate some probabilities with more difficult systems. So I hope you've managed to get a copy of the sheet. If you haven't, remember to put the title probability 2 and write the objective and today's date in your maths book as if this was an ordinary lesson. So working out probabilities for more complex situations can be a problem. Just let me read out this example and just see what you make of it. If I flip 4 coins at the same time, what is the probability at least 3 of them land on a head? Now, the answer to that isn't something that you are going to be able to guess. Off the top of my head, I don't even think I know what the answer to this is immediately. I would need to do some working out. How many different things can happen when I flip those 4 coins? That is what we need to consider. We need to make a list and figure that out. So let's imagine I had 4 different coins. And the reason why I'm going to talk about 4 different coins in a minute is quite important. Now, I could throw all of these coins up in the air and they all land on exactly the same side. They could all land on a head. So I'm going to use the abbreviation H for head. So I could have a scenario where all 4 of them are heads. I could have a scenario where I get 3 heads and a tail. However, there's actually more ways than 3 heads and a tail can happen. Because if you just imagine my different coins for a minute, that 3 heads and a tail is where the tail is on the 50p. But I could have different combinations of 3 heads and a tail, and that tail be on one of the other coins. It's always a really good idea when you're making some sort of list to try and do things in a logical order. So I'm now going to do all the different combinations of 3 heads and a tail, where the tail slowly moves along the line. So that would be 3 heads and a tail, where the tail is on the 20p. And so on. That's another outcome. So each row is an outcome, 3 heads and a tail, but where the tail's on the 2p. And then finally, 3 heads and a tail, where the tail is on the 1p. So that actually happened in 4 different ways. We've now got all the different combinations of 2 heads and 2 tails to figure out. So again, I'm going to try and do this in a logical order, where I start with 2 heads and 2 tails and then do the exact inverse of that. Then I'm going to have the heads on the outsides and do the inverse of that. Have I got them all? No, I think I need some alternating heads and tails. Do the inverse of that. Is that all combinations of 2 heads and 2 tails? Now what are we missing? Well, I need the combinations of 3 tails and 1 head. So I'll do that in a similar method to what I did previously. Just shuffling that head along one place as we go. And I'm starting to run out of space. But there is one more combination with the 4 tails. So, how many different combinations can happen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So remember, each row represents one combination. Now we've got all the things that can happen, it's actually a lot more straightforward to answer this question. What is the probability of at least 3 of them will land on a head? So where are the ones where at least 3 are heads. It's that one there, that one there, that one there, that one there. But don't also forget that 4 heads is at least 3 heads. So that is counted as well. So the answer to this question is now 5 out of 16. So by making a list, we've managed to answer that question. In my second example, we're just going to look at a situation where we are listing some combinations, all the different things that can happen. So Ben is allowed to choose a choice of lunch mains from pizza, fish and chips, sausage and mash, and desserts from chocolate, ice cream, and fruit. What are all the possible combinations? So obviously I'm going to use some abbreviations here. Need to be a little bit careful with fish and chips and fruit because they both start with F. So I think I'll use a different abbreviation for fruit, maybe a capital F and a lowercase r. So I'm going to list this by putting the mains and the desserts. And I'm again going to go through this in a logical order so I don't miss out any combinations. So I'm going to do all of the combinations with pizza first. So you could have pizza with a chocolate dessert, pizza with ice cream, pizza with fruit. Now I'm going to swap out to fish and chips with chocolate, fish and chips with ice cream, fish and chips with fruit. And then finally, sausage with chocolate, sausage with ice cream, and sausage with fruit. So we can see there are 9 possible outcomes. Both examples that we've looked at so far have just involved us writing a list. Well, if you have something a little bit more complex, you might choose to use a sample space. And a sample space is pretty much equivalent to a list. It's often just a table showing you all the different outcomes. So, it says Joey rolls 2 dice and adds their total. What is the probability his total is 9 or more? Again, a very difficult question to ask if you didn't have information about what all the outcomes look like. So I've drawn a little table. It's a little bit like a times table grid, showing all the different things that can happen when you roll 2 dice. And in the grid, we just need to add up the different values. So for example, if I got a 5 on dice 1 and a 2 on dice 2, that would be a total of 7. So all I need to do is complete this grid. And as you're filling it in, you will spot there are some patterns. So I've jumped ahead where I've filled in all of the outcomes, and immediately what you'll notice that some outcomes, some totals, are more likely than others. When you roll 2 dice, the most likely outcome that you can get is 7. And the reason it's 7 is because there's more ways that you can make 7 with the numbers on 2 dice than any other number. Likewise, the numbers 2, where it's 1 and 1, and 12, where it's 6 and 6, are very unlikely outcomes. Altogether, there are 6 times 6, 36 different things that can happen. But anyway, let's go back to our question. What is the probability his total is 9 or more? Well, we can now find this very quickly in our table. How many of these are 9 or more? 4, 5, 6, 7, 8, 9, 10 ways. So if I go back to my probability notation, I could write probability that T, total, is greater or equal to 9 equals 10 over 36, which cancels to 5/18. So there's various questions for you to try. We've got the normal level 1, level 2, level 3 questions. Please pick and choose which questions you are going to try today. And as always, the answers are at the end of my PowerPoint, so use the last 5 minutes to check and make any corrections. As always, if you have any problems with today's lesson, please contact your teacher in the Ask the Teacher channel.